Hey, what's up, students? Let's do the boom roasted. I got that one from Hadley and Brinley. They say that all the time, even when they don't really roast each other. They're like, hey, Hadley, look, your shoes are untied. Boom, roasted. Ha ha ha. It's pretty funny, though. Okay, find the greatest common factor. So this is very similar to the offhand ban. We just have larger numbers. So big whoop. The variables are actually the easiest ones, okay? So x and y. What's the most you could take out of an x to the 5 and an x to the 3 without making a mess? An x to the 3. If you try to take out more, you'd make a fraction, and fractions are bad. What's the most you could take out of a y to the 6 and a y to the 10? Just a y to the 6. So it's really easy. The variables are really easy. You just pick the smaller of the two, okay? That's the most you can remove without making a mess. All right, let's go to the numbers. 150, 190. Make a little factor tree really quick. This one's actually kind of obvious. If you're really good at making factor trees in your mind, go for it. If not so much, make a factor tree then. Here we go. All right, so the first thing I break it down is divided by 10, divided by 10. So 19 and 10, and then I could break down 15 and 10 some more, but there's really no point because I don't think 15 and 19 are gonna have anything in common. 10, that's the greatest common factor. So the greatest common factor of the numbers is 10. The greatest common factor of the variables is actually the smaller of the two. It's weird because it says greater, but you actually pick the smaller one. It's kind of misleading. It's kind of asking for what's the most you can take out without making a mess. Well, x to the 3. And then for the y values would be a 6. So there it is. Okay, that's the most you could take out of these two monomials without ruining it, without getting decimals or out getting fractions. You don't want either of those things. All right, cool. That is the boom roasted.